Review 1.02 Triangle Similarity. We're going to determine missing measures in similar triangles and determine the postulates or theorems that prove the triangles are similar. Similar figures are the same shape but not necessarily the same size. We use this symbol to show similarity. Shown here are similar. In similarity statements, we always want to make sure that the corresponding vertices are in the same order as you do congruent statements. You can prove that two triangles are similar by using the polygon similarity postulate, which means proving that the three pairs of corresponding angles are congruent. Fortunately, with triangles, it isn't necessary to prove that all pairs of corresponding angles are congruent and all pairs of corresponding sides are proportional. Instead, we can use these three theorems or postulates: the angle-angle similarity postulate, the side-side-side similarity theorem, and the side-angle-side similarity theorem. So let's try our first two triangles. We're going to determine whether the pair of triangles are similar. If they are, we're going to write a similarity statement and we're going to justify our answer. We never want to assume that the side lengths or the angles are drawn to scale. Only information given or marked can be assumed. So here we have triangle ABC and triangle CDE. Notice that AE is serving as the transversal and that AB is parallel to CD, as well as BC being parallel to DE. The double arrows on BC and DE indicate that BC and DE are parallel. With AE acting as the transversal, we see that angle BCA is congruent to DEC using the corresponding angle postulate. Therefore, the measure of angle BCA is equal to 69. The same is true with the single arrows on AB and CD. Since they're parallel and AE is acting as the transversal, then angle CAB and angle ECD are corresponding angles. Using the corresponding angle postulate, we know that angle A and angle ECD are congruent. Since we have two angles that are congruent in triangle ABC and triangle CDE, we can say that using the angle-angle similarity postulate, triangle ABC and CDE are similar. Now let's look at triangle PRQ and triangle SRT. Notice that PRQ is included angle R and SRT has included angle R. Since R is vertical angles, then they're going to be congruent. So we can look at SR being proportional to RP. 10 over 15 can simplify to 2/3. Then we can look at TR being proportional to RQ. 8 over 12 simplifies to 2 over 3. Since T over QR is proportional with SR over PR, We have two sides with an angle in between that's congruent, and we can say since SR over PR equals TR over QR, which is 2/3, then those two sides are proportional and angle PRQ is congruent to angle SRT. So triangle PRQ and SRT are similar using the side angle side similarity theorem. Now let's determine the pair of triangles, this pair of triangles as similar. Notice that we have all three side lengths to both triangles, so we can set up proportional sides, but know that we have to do all three sides to make sure that these triangles are similar. The first side that we're going to use is DE. So when we set up the proportion, we see that DE corresponds with AB. So we would say DE over AB, which is 30 divided by 60. 30 divided by 60 is 1/2, or 1/2. Now we're going to determine the ratio of EF to BC. Notice that EF divided by BC is 20 divided by 40, which is also 1/2. Remember, with side similarity, we have to have all three sides. So let's do the third side, FD to CA. When we set up this ratio, we see that FD over CA is equal to 35 over 80. When I simplify that down, 35 over 80 is equal to 7/16. When you compare the ratios, you can see that they are not all the same. For triangle ABC to be similar to triangle DEF, the ratios must all be the same. So we can safely say that triangle ABC is not similar to triangle DEF. Now we can determine the value of x with the same information that we've already been doing. Notice that we have a triangle here, but we're missing the length of this line segment. So the first thing that we're going to do is we're going to take triangle PST and triangle PQR, and we're going to notice that they share angle P. Using reflexive property of angle congruence, we can show that angle P of both triangles are equal. Then we notice that the figure shows that ST is parallel to RQ and that PR is used as a transversal. So angle STP and angle QRP are corresponding angles. Therefore, angle STP is equal to angle QRP using the corresponding angle postulate. Angle STP congruent to angle QRP. We now have two angles in triangle PST congruent to two angles in triangle PRQ. Thought there was a glitch in my video. We can use this information that we've learned to solve for missing measures. So here we can set up a proportion TP over RP is equal to PS over PQ. We see 60 over 60 plus x is equal to 25 over 25 plus 50, which is 75. In order to see if these are proportional, or in order to solve for x, we're going to cross multiply. But before we do that, let's simplify. So we have 1 over 3. Why we say 60 times 3 is equal to 60, or x plus 60. 60 times 3 is 180. Then we go ahead and we subtract 60 from both sides, which tells us that x is equal to 120. Given triangle MNO is similar to triangle ABC, NO is equal to 2x plus 2. B is equal to 5x minus 2 for the value of x. In similar triangle MNO and ABC, MN and AB are corresponding sides, and NO and BC are the corresponding sides. So we can set up the corresponding angle or the corresponding sides as proportions. Notice that we would substitute MN with 5 and AB with 9, and then NO with what was given to us, 2x plus 2, and BC with 5x minus 2. When we do that, we'll cross multiply so that we get 5 times 5x minus 2 is equal to 9 times 2x plus 2. 5 times 5x is 25x. 5 times negative 2 is negative 10. 9 times 2x is 18x. 9 times 2 is 18. Subtracting x from both sides, we get 7x is equal to 10 equals 18. Adding 10 to both sides, we get that 7x is equal to 28. Dividing both sides by 7, we get that x is equal to 4. If you have any questions about this lesson, please reach out via email or text. Have a fabulous day.